Okay, for part 3, what we're looking at is opaque materials, shadows, and eclipses. So most materials are opaque to visible light, and oops, no. Okay. So, so anyway, so when we look around us, most of the materials we're looking at are opaque, unless you live in a glass house. So you've got walls and you've got furniture. Most of those are opaque. Now, that doesn't mean that light doesn't interact with those objects. Yes, they can block light and create a shadow, but light can also reflect off them. So we see this bridge because light reflects off the sides of it. And so most things we look at, we see the light that is reflecting off the object. Okay? So we're not just talking about, when we talk about opaque, it's a material that light doesn't transmit through, but it could be absorbed or it could be reflected instead of being transmitted. Okay, so shadows occur and when light is blocked. And the thing is, if we have a faraway source like the sun, we get very nice, sharp shadows, very clear. But if we bring the source closer or the object closer to the source, then what we get is a fuzzy looking shadow. And we talk about its two parts. The umbra is where the light is totally blocked. That should be black. And then the penumbra, the partial shadow, is that fuzzy part around it. And so this can change for the object as conditions change. So over here, I've got a lamp and so some scissors, and you can see that the shadow is nice and clear when I'm far away from the light source. But then as I bring my hand up closer to the light source, the shadow starts to be fuzzy, right? It has fuzzy parts. Some parts are darker black, but it's fuzzier. Okay, so it's sharp and then fuzzy. So this is something you can do at home, right? Oops. Only better than I'm doing it probably. Okay, all right, so very fuzzy as I bring it well away. Okay, now two things we're going to talk about are lunar eclipses and solar eclipses, which are both about shadows. The word eclipse means to shadow. So lunar refers to the moon. The moon is eclipsed or in shadow. And that occurs because the Earth does have a shadow behind it. But the moon's orbit is at like 5 degrees, so it usually misses the shadow. But sometimes a full moon will pass in the shadow, and in that case, it is eclipsed. Now, solar eclipses occur when it's the sun that is eclipsed because the moon gets perfectly between the sun and the earth. And one of the weirdest things, the coincidences in our earth history, is that our moon is the right size and distance that it blocks the sun perfectly. It just covers right up the face of the sun. It's just one of those marvelous coincidences that occurs. And so that which is very convenient for us. Now that doesn't happen for other planets. Mars has some little moons, but they're very small, and they don't block the sun. They will pass in front of the sun, but they don't block it completely like our moon does. And even our moon doesn't always block it completely. Sometimes it's a little too far away because it does have that elliptical orbit. And when it's closer, then it blocks it, but it doesn't overlap perfectly. So anyway, so yes, so some eclipses aren't completely total. All right, so let's look more at the solar eclipses. Now, solar eclipses happen when there's a new moon. So new moons occur once every 28, 29 days, so once a month. And so you have the moon is closest to the sun. And So what happens is that the shadow cast by the moon when it passes in front of the sun sometimes hits the earth. Now it's a tapering shadow, so by the time it reaches the earth, it's just a very, very small place, about 40 to 90 to 100 miles wide, the shadow of the moon, and you have to be in that location if you want to see the eclipse. Now, you can see a partial eclipse, though, if you are in the umbra versus the penumbra. So the umbra, if you're in that small location, you're going to see the total eclipse. But if you're in the penumbra, the partial shadow, then you'll see a partial eclipse. So when the big eclipse happened in 2017, if you drove down further to the south, like I did, I got to see a total solar eclipse. But if you stayed up here, you were 200 of miles away from the point where you would see the total eclipse, and you would just see a partial eclipse. So you would see a crescent sun, whereas I got to see the total eclipse. Okay, so solar eclipses are when new moons block some or all of the sun's rays, and the moon has to lie in between the sun and the earth in nearly a straight line. So, so you could be asked a question, what's the order for a solar eclipse? Is it sun, moon, earth? Is it earth, sun, moon? Is it sun, earth, moon? Okay, well, the moon is in between the sun and the earth. So that must be this answer, right? Sun, moon, earth. And by the way, you can't fit the sun in between the earth and the moon. At least it doesn't go there. Okay, so we have the sun, the moon, the earth. We have an umbra and a penumbra. And what happens, though, is the earth is moving and the moon is moving. So what happens is that location on the earth travels a pathway. So as you know, when the eclipse happened in 2017, there was a path across the planet that you could go to, whoops, not that one, to look at the eclipse, which you get a path that's published. Okay, so solar eclipses are lots of fun if you get a chance to go see them. And so you don't have to wear your glasses if it's in totality, which is where the sun will and the moon are directly on top of each other. So all you're seeing is the beautiful corona, which is the outer atmosphere of the sun. Now, the one in 2017, the corona wasn't quite as fancy. It just looked something like this, kind of more of a triangular shape. It depends on where it is in the sunspot cycle, evidently, something like that. But there is going to be another eclipse coming up in 2024, so just a few more years to wait, and you will be able to go to that one. So in 2010, there was what was called an annular eclipse. An annular eclipse is when the moon is a little too far away from the Earth, and so it doesn't block the sun totally, so you get a ring around the sun. So that one you have to keep your glasses on. And there was an eclipse, and I made these slides up in 2010, so you can get these slides at NASA. This one went through Easter Island, so there's a lot of ocean. So people take boats out to watch eclipses because it's pretty cool on a boat, I guess. Anyway, so people went to Easter Island, but one of the problems is you get clouds. So during totality in 2017, I missed about half the eclipse because of a cloud that decided to drift over at that time. Okay, so anyway, partial solar eclipses are great though for taking photos. So when those occur, you'll get news information in the newspaper that says what you're expecting to see, where you live. So like we were about here, So we were able to get 0.54 eclipsed. Okay, so 0.54 sun, so 48% eclipse. And so I took a picture of it. So that's what it looked like. Now this was taken through X-ray film, which isn't the recommended way to do it. But I like that it's not a total filter, because otherwise you just get a picture of the sun. But it does not protect you or your camera from ultraviolet rays. So you don't want to just look through X-ray film, which you can buy at Science Surplus, old X-ray film. Okay, so anyway, so you can do projections with telescopes or make holes in a paper plate or use a colander or tree shadows to make images of the eclipse. Okay, now eclipses don't happen that often. So they usually, NASA puts out these 20-year path things from 2001 to 2020 across the United States. This blue line here is the eclipse that happened in 2017. And that's the only total solar eclipse that went across the continental United States. Okay, red is for annular eclipses. All right, so 1 in 20 years across the United States. So what about the next 20 years, 2021 to 2040? Look at the United States, one blue line. So this is the one that's coming in 2024. So if you don't go to that one, then you have to wait till like 2045 or something for the next one across the United States. And this one's nice because it's a little wider path. It's going to last longer, 4 minutes instead of 2.5 or so. And it's really close to us again. So you could go down south, or you could go to Indianapolis, or you could drive down to Texas. But it's going to happen in April, so there might be clouds. So you might decide to drive south to get a better, hopefully clearer view. Anyway, so weather conditions will be iffy. It'll be great to see what happens in 2024. Anyway, so don't miss it, because otherwise you have to wait 20 more years. Or go to Australia. Australia here, you can see, has like 6 eclipses in this 20 years. The closer they are to the equator, the more eclipses they're likely to have. Okay, and you can go to nasa.gov and type in eclipse, and you can find lots of information. Yeah, lunar eclipses happen, as I said, when the Earth's shadow falls on the moon, or the moon passes into the Earth's shadow. And the moon is moving slowly through the shadow. So unlike a solar eclipse, which only lasts like 4 minutes, the lunar eclipses, they can last for 3 hours for the total thing. Usually the good part is about 1.5 hours, even in a long eclipse, so about 90 minutes. And this is a full moon. And so it passes through the shadow. Now, some parts of the shadow are deeper, right? There's the umbra and the penumbra. So the best part is when it passes through the umbra. That's when you're going to see the spectacular color changes that occur. Because what happens is you get to see a red moon, which can be very spectacular, especially if it's a long eclipse. And what's happening is that the light from the sun, as it passes through the atmosphere, you get red sunsets. And the thing is, that light continues past where you're watching the sunset, and it will hit this moon and make it red. And so that's the really fun part to watch, is the light that is the longer wavelengths that survive the trip through the Earth's atmosphere, curve around the Earth, and hit the moon. And so anyway, so you'll get, so as it passes into the umbra, that's when you're going to start seeing the color changes. And that can last for up to 90 minutes. And so you get all the pretty colors. And those are what are called the blood moon, when you get the really spectacular red color. So anyway, so those are something interesting also. Okay, so that is the end of this part. And we're going to go on and talk about the eye and vision.